Welcome! Today, we are going to peel back the layers of our digital world and decode the secret language that powers pretty much everything you do on a screen. It's a language that's so simple, but it's also powerful enough to build entire virtual worlds. So let's just dive right in.
Have you ever really stopped to think about that? How does this little slab of glass and metal actually know what you want when you tap an icon? Or how does it find your favorite song in like a split second? It feels like magic, but it's really not.
Well, the answer is way simpler than you might think. It all boils down to a language that only has two letters, a 0 and a 1. That's it. This is binary, and it is the foundation of everything from the simple text message you just sent to the most complex AI systems changing our world. To really get our heads around this, we have to start at the most basic level. I'm not talking about software or code, but with a real physical object. A tiny, tiny switch.
This little thing right here, it's called a transistor. Deep inside your computer's processor, there are literally billions of them, and each one is just a microscopic switch that can be flipped on or off with a little zap of electricity. They are the physical heart of every single thing a computer does.
So, think about it. Each one of these billions of switches can only do two things. It can be off, meaning no electricity is flowing, or it can be on, with electricity flowing right through it. That's it. That simple, two-state system is the absolute key to everything. And here is where it all clicks. We just assign a number to each of those states. The off state becomes the number 0, and the on state becomes the number 1. And just like that, we've turned a physical state, on or off, into a piece of data. This is it. This is the birth of binary code.
Okay, so one little switch by itself isn't all that useful, right? But what happens when you start stringing them together by the millions and billions? Well, that's when we get the real building blocks of all digital information.
Each one of those zeros or ones has a name. It's called a bit, which is just short for binary digit. You can think of it as the atom of the digital universe. It is the absolute smallest piece of information a computer can possibly understand. Now, to make these bits useful, we group them together. The standard group size that computers use is 8 bits, and a group of 8 bits is what we call a byte. If a bit is like a single letter, then a byte is kind of like a full word. It's just a more convenient chunk to work with.
And this is where things are going to start sounding really familiar. See, we group bytes into kilobytes, then kilobytes into megabytes, then megabytes into gigabytes. So next time you hear that your phone has 128 gigabytes of storage, you'll know what that really means. It's just a way of saying it can hold information from billions and billions of those tiny on-off switches.
All right, so we have all these long strings of zeros and ones, but they're just numbers, right? So how does a totally meaningless string of numbers turn into a photo of your dog or your favorite song, or even just the letter A? Well, that is where context becomes everything. Take a look at this byte. It's just a pattern of 8 bits. On its own, it means absolutely nothing. It's just a sequence of on and off switches. So yeah, what does it represent? How does a computer have any clue what to do with this specific pattern?
And the answer, which is kind of brilliant, is it all depends on the context. The computer is told how to interpret it. That exact same pattern, 0, 1, 0, 0, 0, 0, 0, 1, could be the number 65. Or if the computer is processing text using a standard called ASCII, it means the capital letter A. If it's part of an image file, it could define the specific color of a single pixel. The binary is the same. The meaning is all about how you interpret it.
Okay, so the theory is great, but let's actually get our hands dirty. Believe it or not, you can learn to speak this language right now. We're going to do a quick conversion to see what one of our regular numbers looks like to a computer.
We're going to take a totally normal, everyday number. Let's go with 84. And our mission, should we choose to accept it, is to translate that into its 8-bit binary form. To do this, all we need is this little cheat sheet. You know how in our normal counting system we have a ones column, a tens column, a hundreds column, and so on? Well, binary is base 2, so instead of going up by powers of 10, each column just doubles. 1, 2, 4, 8, 16, 32, you get the idea.
Okay, here's how the logic works. We start with our number, 84, and we look at our biggest place value, 128. Does 128 fit into 84? Nope, too big, so that spot gets a 0. Next up, 64. Does that fit? Yes, so we put a 1 there and subtract it, which leaves us with 20. Does 32 fit into 20? No, another 0. Does 16 fit? Yes, it does. Put a 1 there. We're left with 4, and so on until we get to 0.
And there you have it. The number 84 in binary is 010101000. Each one just represents a place value that we turned on to add up to our number. See? You just spoke binary.
So, why go through all that? Why does any of this matter to you? Well, because once you get this, you start to understand how and why our digital world works the way it does, including its limits. Take photos, for example. You've probably heard of an 8-bit image, right? Well, that bit depth just tells you how many bits, how many zeros and ones are used for each pixel's color. An 8-bit image can only show 256 different colors. But a 16-bit image, that can show over 65,000 colors. More bits just mean more possible combinations, which gives you more detail and more complexity.
This also totally explains file sizes. A simple text email is just a few thousand bytes, a few kilobytes. But a high-res photo, now you're talking about millions of bytes, or megabytes, because it has to store all that color info for millions of pixels. And a movie? Forget about it. That's billions of bytes, gigabytes, representing every single frame and sound.
So just take a second and let that sink in. That game you love to play, that song you're streaming, that photo you just took, at the deepest level, it is all just a massive, incredibly fast river of zeros and ones, representing billions of tiny switches flicking on and off. And that brings us to a final thought. Really, a question for you. You now understand the fundamental language of all modern technology. So, how could knowing this secret language help shape your future? Whether it just gives you a new appreciation for the tech in your pocket, or maybe it even sparks a new passion or career path. You now hold one of the most important keys to our modern world.